Okay, up above you used this system before and you wrote a matrix equation, so if you just want to copy it down where it says rewrite the matrix equation below that you wrote above for the system on the left, if you want to just write down what I have written right there in that space. When we have a matrix equation like this, we will call this part A, matrix A, and this is matrix X, and this is matrix B. And so what we have is we have A times X equals B. And so we'll use that in just a second as we refer to other things. To solve using inverses, just like we did for the very first problem in video number 1, we're going to multiply both sides of the equation, the A x equals b. We're going to multiply both sides by the inverse of the matrix. So we're going to multiply by the inverse of matrix A and the inverse of matrix A right here. One thing that's very important to remember is that since matrix multiplication is not commutative, if you multiply A to the negative 1 times A, you have to do A times negative 1 there and not B times A to the negative 1. And that's why I left this space. You'll notice that I have a space right there, and that's why I've left that, because I'm going to have to put a matrix in here in this space. Okay, so we're going to go ahead and use the inverses to find the solution for this system with our matrices. The first thing that we have to do is first we're going to have to find the inverse of matrix A. And so we are going to do that by finding the determinant. So we'll do 2 times 1, subtract 1 times negative 1, and so that's 3. So we're going to have 1 over 3 times, and then we switch that matrix around and change the signs on the others. And then we're going to perform the multiplication. So we're going to get 1/3, 1/3, negative 1/3, and 2/3. Okay, so now we're going to come over here and take this matrix inverse, and we're going to write it next to our matrix equation we already have so we can perform the multiplication. So go ahead and write that down. We're also going to insert it right here, because if we do it to one side of an equation, we have to do it to the other side of the equation, just like we've always done. Okay, once we've got this, you'll notice that we now have the inverse times the matrix and the inverse times the constants. And so we've done the same thing to both sides. So on your notes you should be where it says second, multiply both sides by a to the negative 1. You should have written this there. Now let's look and see what happens on the left-hand side of our equation. When we do this multiplication, we're going to do this row times this column. So we have 1/3 times 2 plus 1/3 times 1. Then we're going to do this same row times this column. So we're going to have negative 1/3 plus 1/3. Then we're going to do this row times the first column. So negative 2/3 plus 2/3. And then we will do this row times this column. So that's going to be positive 1/3 plus 2/3. And we'll leave everything else over here the same. And then on the right hand side, we're going to do this row times this column. So that's going to be 1/3 times 8 plus 1/3 times 4. And then we're going to do this times this, so negative 1/3 times 8 plus 4 times 2/3. Okay, now simplifying everything, we are going to have over here 2/3 and 1/3 is 1, negative 1/3 and 1/3, that's 0. Negative 2/3 plus 2/3 is also 0, and 1/3 and 2/3 is 1. So you'll notice, and I ask a question on the notes there, what do you have here on the left? What happens? You have the identity matrix. Now remember, the reason why that happens is we just multiplied a matrix times its inverse. Over here on the right, we've got 8/3 plus 4/3 is 12/3, and negative 8/3 plus 8/3 is 0. Since we have the identity matrix on the left here, that's multiplying by xy, it's just xy, because remember it doesn't change anything. And then we can simplify 12/3 to be 4, and what this means is x is equal to 4 and y is equal to 0. So on your notes, where you've got where it says what you have left is your answer, we translate that into the ordered pair for 0, and that's how you use inverses to solve matrices. Or, sorry, inverses of matrices to solve systems. Okay, let's try another one. Okay, on the next page we're going to do a second example with this system. So the first thing that we're going to do is we are first going to write our matrix equation. So let's write the matrix equation, leaving room for what we know is going to happen. Whoops, and I just didn't do that. Okay, now to use our inverses, the first thing we're going to do is find the inverse of this matrix A. And so I'm going to do 1 times 1, subtract negative 2 times negative 4, so that's positive 8, so that's negative 7. So my inverse will be 1 over 7, and then we're going to multiply by that switched around matrix. And that's going to equal 1/7, 4/7, 2/7, and 1/7. Okay, that's our inverse, so I'm going to insert that right over here. And doing it to the other side as well. Okay, now as we saw in the last problem, what's going to happen is if you have done this correctly, the product of these two matrices right here is going to be the identity matrix. And so we are going to just assume that we did this correctly because we can always check our answers at the end to make sure we did it right. So over here on the right, I'm going to have 1/7 and 4/7 multiplied by this column, so I'm going to have 10/7 plus 4/7. Then I'm going to do this row times this column, so that's going to be 20/7 plus 1/7. So that means that the matrix XY is equal to 10 plus 4 is 14/7, so I've got 2, and 20 plus 1 is 21 over 7, that would be 3, which means that my solution is 2, 3. Now remember that I can always check this by coming back up to my original problem and plugging in 2 for x and 3 for y and seeing if it's right. So let me erase some of this so I can have some space. So I've got 2 minus 4 times 3 equals 10. And I can see right away that something's wrong there. So when that happens, I have to go back and find out what the problem is. Now, some of you might have caught this earlier on, but what happened was right over here when I found my determinant, I said 1 minus 8, and that was negative 7. And when I multiplied by this 1 over my determinant, I just put 1/7, not negative 1/7. So all of these all of these numbers here need to be negative. And so this is one really good reason why you would want to check your answers, because if you miss one little thing like that, everything else is going to be wrong. So let me go through and correct what needs to be corrected here. So assuming that now this part is right, I would have negative 10/7 and negative 4/7. That would be negative 14/7. I would have negative 20/7 and negative 1/7, negative 21/7. So now I'd have negative 2 and negative 3. So now if I try to check that answer, I'm going to have negative 2 minus 4 times negative 3, so that's plus 12, and that equals 10. That works, so let's hope the other one does. Negative 2 times negative 2 plus negative 3. That's 4 minus 3 is 1, and that works. So that's just a good example of, even though you might want to just say, oh yeah, this is always the identity matrix, you need to make sure that your answers really work, because if you don't check it, you won't know that you have the wrong answer. Okay, so the answer to this problem is the negative 2, negative 3, and we've checked that. Okay, the last one we're going to do here is this system, and so the first thing that we're going to do is we're going to write our matrix equation. So 1, negative 3, 2, negative 6, and then our variable, and then our constant. The second thing I'm going to do is, very carefully this time, I'm going to find my determinant. So I'm going to do 1 times negative 6 minus 2 times negative 3. Now negative 6 minus negative 6, that is 0. And what have I learned about when the determinant is 0? If you remember, I cannot find the inverse because you can't do 1 over 0. That's undefined. So that means that there's no inverse. So if there's no inverse, what am I supposed to do? So you might think, well, we can solve it another way, and yes, you can, but this actually tells us something. If a matrix doesn't have an inverse, it is called singular. So it's called a singular matrix, and this means that there is no solution. And we've seen that before. It is also what we call inconsistent. And we've learned about that before. On the graph, if I was to graph my system, it would show parallel lines, and that's how you can check to see if you did it right. You can see if you graph it, does it really show parallel lines, because if it doesn't, then there would be a solution.